This project is sponsored by PCBWay. This year, PCBWay is celebrating the 10th anniversary of its successful existence. On the occasion of this event, PCBWay provided its users with more conveniences such as big savings for certain products as well as discount of up to 80%. Log into the PCBWay site and start the PCBWay 10th anniversary tour, where you will enjoy coupons, lucky draw, exclusive badges, unboxing blind boxes and many other surprises. PCBWay is always your great choice. Hello, Teremino is an open source system to connect computer with the real world. Unlike similar systems, for example Arduino, the system works immediately and does not require any firmware programming. The communication between the PC and the external components is done through Teremino Master Board, which is just an input-output device and not a microprogrammable controller as Arduino. You can get the Teremino Master Board ready for about $20 or make it yourself because the code and instructions for making it are free. Now you have more than 150 great Windows applications on the Teremino website that allow you to control the components, modules or sensors connected to the Teremino Master Board. The Teremino systems uses the power of the PC and the flexibility and low cost of the microcontrollers. So with this combination we can make great devices. This time I will present you a simple way to make an ultrasonic sonar where the radar-like display is actually a Windows-based application with the possibility of more settings. The excellent Windows application was developed by Mauro Roboni and reworked by Teremino team, and you can view the original project on the Teremino site. The device is extremely simple to build, in fact like all Teremino projects, and consists only a few components. Teremino Master Board, few resistors, CSR04 ultrasonic sensor module, and cheap 9 grams servo. In order to save time, this time I used cases from some of my previous projects. And now let me explain the installation and setup method in a little more detail. First we connect the device to the USB port and open the Teremino HAL application. As we can see in the schematic diagram, the servo motor is connected to pin 1 and the ultrasonic sensor to pin 2 of master board. For pin 1 we need to select servo 16, and for pin 2 sound sensor. According to the author's instructions, here you should put response speed 100 and disable remove errors. Also the max distance that you set in the properties of the pin type sound sensor in the application HAL must match the scale to set in the Teremino radar application. So slots 931 for servos and 932 for sound. This completes the setup of the Teremino HAL and we can start testing the device. Now let's take a look at the Teremino radar application. The bottom tab shows the current angle of the ultrasonic sensor, the distance to the obstacle, as well as the defined slots for servo motor and sound sensor. These slots need to be entered into the Teremino HAL application. On the right side of the interface there are 3 sliders, one for the default settings of the scanning angle, the second for the scanning speed, and third for the determining the distance at which we want to scan. This distance can be changed from 10 centimeters to 10 meters, but in our case it is limited by the limit of the sensor, 4 meters, and there is also an auto scan button. Now let's see how the device works in real conditions. By starting the Teremino radar application, Teremino HAL, which we set up earlier, is also automatically started minimized. This is Teremino HAL. The scale distance should be set to equal the distance defined in Teremino HAL, which is currently 0.5 meters or 500 millimeters. By pressing the auto scan button, the scan starts. Radar-like display shows the obstacles that are placed in front of the sensor, and the distance is read on the scale of concentric semicircles. With the speed slider, the speed is changed. And with the angle slider we can scan a certain range in the front of the sensor. As we can see, the movement of the sensor is homogeneous without jumps and shakings. Next, we can decrease the scan distance, which will increase the accuracy of the closer object, or vice versa. And finally, a short conclusion. As far as I could tell, this is the first version of the do-it-yourself radar look display sonar, based on which many Arduino versions were later made. However, this Teremino version, thanks to the stronger microprocessor and the well-made software, is in every way better than the later similar devices made with Arduino microcontroller board. In fact, the basic feature of all Teremino projects is minimal hardware without programming and visually and functionally superior Windows software, which ultimately results in a great project.